correct way to do each of these problems. First, we have Cl2. This will be one of the easier ones because you have chlorine. You have chlorine. They have a bond right there, and who wins tug of war of electrons? Neither. So it's just going to be nonpolar. Okay, let's move on to HCl. H bonds with Cl. Who wins when they fight over electrons? That'll be chlorine. And so your final dipole moment just looks like that. You only have one bond to think about, so you don't have to do any type of combination. Let's do CCl4. We have carbon. We have chlorine. We have chlorine. Chlorine. And then chlorine. And then what's going to happen is chlorine just keeps beating carbon. And all of those in 4 different directions cancel out, so it's nonpolar. So nonpolar is our answer for that. Okay, now we get to some harder ones because they're charged. We have, oh no, I'm sorry, not yet. H2O. We have O, H, H, O wins, O wins. So we have 2 going towards O, so you combine those, and you'll have a dipole moment that looks like this. That's your final dipole moment for this. Okay, now we get to the charges. We have O, and we have 3 H's. So it's going to be an H, an H, and an H. And so this will bond, this will bond, this will bond, and because it's a plus, we can eliminate one of those electrons. So it works out. So this is what it will look like. But in order to do this right, you need to draw it with the correct shape. This is where the correct shape is extremely important. When you have 2 on top, remember, it makes it not a random cross with the top missing, but it's pyramidal. So pyramidal will look like this. See, it's an important difference. And so what happens is you go up at an angle. You go up at an angle. Those, their left and right push cancels out, and all that's left is going straight up. And then obviously this is going straight up. So you combine all that, the final dipole moment is just straight up like that. That's the final dipole moment. These little individual ones don't matter. What matters is your final answer on there. Okay, OH minus. So we have O. We're going to have H. They bond, and we get a minus, so we get to add an extra electron to the O. So O will look like that, where it gets an extra electron. Obviously, this is going to be simple. There's our final answer. Okay, it just goes towards O. H2S, this is going to be exactly like H2O. Same exact situation. S beats H, S beats H. Final dipole moment looks like that. We have 2 more. So CO2. CO2. C's out of electrons, so they get to be linear. So it goes towards O, and that cancels out, so it's nonpolar. And then lastly is going to be a very similar situation. C double bonds to an O, but then it double bonds to an S. So in this, remember this is the last one I did in the lesson, you got to pull up your periodic table and look at O and S, and you'll see that O is higher. So we can then assume that O would beat S, and so it goes towards O. See, because it would be like this, going towards S, going towards O, but because O and S are different electronegativities, they don't cancel each other out. Instead, O beats S, so it goes to that direction. All right, that is your final answer. So, as always, ask me if you have any questions, and have a good rest of your day.